Next is the quarter circle. You have to find out the moment of inertia for the quarter of circle. So quarter or a quadrant, this is the quadrant. Okay. In the smallest area, you take it this one as a area TA. Okay, here the angle varies from here. This is the 0 degree. From here to here it is 90 degree. That's all. Okay. So this is 90 degree. The varies integration varies from 0 to 90 degree. So this is the smallest elemental area dA of the length or d theta, and the width is dr. The distance from the elemental area to the center is y. Okay, so the elemental area, if you take it, the elemental area center is this dotted point. You can see this. Okay. So the from a dotted element to the base, the distance is y is equal to r sine theta. Okay, y is equal to r sine theta. That is the y distance. Okay. So now the elemental area you need to determine. So elemental area is equal to, this is the dA, we call it as elemental area dA. So dA is length into width. Length is r d theta, or okay, length is r d theta into dr. Okay, next dA we have determined. Next is DIAB. So DIAB, we can, that is what, the small distance, square of the distance, that is y. Okay, that is y. The y distance, I will take the square of the distance into area. Elemental area is dA. Okay, so this, whatever the equation DIAB is there, so I have written as it is here. You can see here DIAB is equal to y square into dA. Y square into dA. So every time if you forget, you have to remember this equation. Okay, so y this dA, y and DIAB, these three equation will be common for all the circle, semicircle and quadrant. So you just mug up. Okay, so it remains same. Okay, if you know these three equation, rest of the things you can solve the whole equation, whole derivation. You have to be mug up these three equation. Okay, next what you do is, just in the place of y you substitute this, in the place of dA you substitute this equation. Okay, that's all. That's what simply you have to do it. Okay, next y square, it will be r into sine theta whole square. dA is r into dr into d theta. Okay, so finally what you will get it, so this will become, if you remove the bracket, it will become r square and r, it will become r cube. So this will become sine square theta and dr into d theta. Okay, this is DIAB. Okay. So if you, this equation, so in order to get I, so I need moment of inertia, so integrate on both the side, both left hand side as well as the right hand side, you have to integrate. Okay. So